Oh my goodness, this video has been so long to put together. I've been trying to get the writing program to work for over an hour and a half now, and I am finally ready to record, or at least I think I am. So, welcome back. It's been over a month since I've making a video, which is why probably that my tablet wasn't working. But we are returning to systems of equations once again. And so this was a question that I found very interesting because I like myself a good systems of equation problem. And so it's a little bit more challenging than the previous ones I've introduced on the channel. And so I'll go through it and you can feel free to go ahead and try to solve it yourself if you want some extra practice. But this is a rather challenging problem, so if you're just getting introduced to systems of equations, don't feel bad if you aren't able to get all the way to the end of this by yourself. So I'll read the problem aloud. A curve with equation y equals ax squared plus bx plus c crosses the x-axis at the point -4, 0 and at the point 9, 0. As well, it passes through the point 120. And then the question that it's asking is, where does this curve cross the y-axis? So we're given the general equation y is equal to ax squared plus bx plus c. So if you don't know what this equation is what's known as the quadratic equation. And so where a is just a constant coefficient of x squared, b is a coefficient of x, and c is the y-intercept of the equation. Because if you plug in 0, which would mean that the point would lie somewhere on the y-axis, but you plug in 0 for x, you get 0 here, 0 here, and then c. So c is what we're looking for in solving this equation. And so the way that we're going to do this is we're actually going to create a system of equations using the points that they give us. So they give us the point -4, 0. So let me write this down. -4, 0. They give us the point 9, 0. And then they tell us that the line goes through the point 120. So then what we do is we plug in all these values into different equations for their respective x's and y's, and then we try to solve for a, b, and c. Ultimately, we want to get c because that will give us our y-intercept. So let me just take a minute and write this down. So we have 120 is equal to a plus b plus c. Then we have 0 is equal to -4 squared. So that's 16a. -4 times x, which is just -4x. And then c. Oh wait, I'm sorry, that was supposed to be -4b. There we go. Plus c. And then 9 squared is 81 times a plus 9 times b plus c. Okay, so what we're going to do for this first step is we are going to try to solve a couple of these equations just like a normal systems of equation. So let's use the first two. So we have 120 is equal to a plus b plus c, and 0 equals 16a minus 4b plus c. So let's try to get rid of this last term plus c, and we'll save that one for last. So let's make this bottom equation negative. So just multiply -1 throughout. So change the signs of all of these to negatives, or change them to the opposite sign, I should say. I thought, well, that's good for me. Okay. Guess I'm just going to have to do this old-fashioned way. What? Did I screw up something? I think I screwed up is what happened. Okay. So minus. Okay. So now, when you combine these equations, these two c's cancel out, and then you add the rest of it together, so you get 120 is equal to negative 15a plus 5b. So now, let's solve for b in terms of a, because all of these terms have a coefficient that's divisible by 5, and so if we add 15a to both sides, we get rid of that, and then we get 120 plus 15a is equal to 5b, and if we divide by 5 throughout, we get b is equal to 120 divided by 5 is 24 plus 3a. So now we have an expression for b in terms of a, and we can use that in these equations up here. So, but first, let's go back. So let's open up the new sheet. So if you don't have any of these equations written down, I would suggest writing them down if you're following along. So now what we're going to do is we're going to take the two equations that were equal to 0. Since they were both equal to 0, we can just take their terms and add them together. So we have, and set them equal to each other. So you have 16a minus 4b plus c is equal to 81a plus 9b plus c. So those c's automatically cancel out, because if we were going to subtract 1 from each side, then those would be gone anyway. So now we just do we just solve here. So let's subtract 9b from both sides. So you get negative 13b on this side, and then you subtract 16a from this side, and you get 65a. Then what we're going to do is, since we already have a term for b in terms of a, we're going to have to get another one. So we divide by negative 13 on both sides, and you get negative 5a. So for those of you who have been following along with this, you may be wondering why we found another way of expressing b in terms of a. Well, now, using the two terms that we found in terms of a for b, we can solve for a. And so we know that b is equal to negative 5a, but we also know from what we solved before that b is equal to 3a plus 24, which means that negative 5a is equal to 3a plus 24. So we can set them equal to each other and get negative 5a is equal to 3a plus 24. So then we subtract 3a from both sides. You get negative 8a is equal to 24. Therefore, a is equal to negative 3. And now not only can we do this, but then we can take this negative 3 and plug it in for a in this equation and solve for b. So now we can say negative 5 times negative 3, which is equal to 15, So b is equal to 15. And now that we have a and b, we can plug it back into the original equation that we had, which was 120 equals a plus b plus c. And now we can solve for c. So we have 120 equals negative 3 plus 15 plus c. So negative 3 plus 15, that is equal to 12. So we have 12 plus c equals 120. And now we subtract 12 from both sides, and you get 108 is equal to c. So that is the y value for the y-intercept. But the question is asking for the y-intercept, so you just have to express that as the point 0, 108. I thought that was a really interesting question personally, but then again, I'm a math nerd with a math YouTube channel, so that shouldn't be all that surprising. If you were having trouble following along with this video, it might be a smart idea to go back and check out the 2 other systems of equation videos that I've made, and that might help you get to the point where you might understand all of this. If you didn't understand it, that's fine. If you did understand it, that's fantastic, because this came from a calculus book. So if you did, that's a great job on your part. That this was a somewhat difficult question that even some people in my class didn't get. And so, yeah.